This is Algebra 2, Section 2.1, Graphing Absolute Value Functions. I'm going to go over some of the key elements in the textbook here. Not every single thing, but what I think are the most important things, and try not to make this video super long. Essential question: how can you identify the features of the graph of an absolute value function? And here in Explorer 1, graphing and analyzing parent absolute value function, the parent absolute value function is this right here. F of x equal absolute value of x. And this thing right here, these absolute value brackets, that's what that is. I call them absolute value brackets. That's what I call them. So this is a parent function. And this just explains that the absolute value is the net or positive difference between 2 points, in this case on a number line. And down here toward the bottom it says the absolute value of x equal the function f of x equals absolute value of x can be defined piecewise. And piecewise is something you haven't heard of perhaps before. That's something that I haven't seen brought up so early. And here a piecewise function is set up in this bracket where you have different pieces, different rules for different portions of the function. And it says f of x equals, in this top line inside the bracket we have x, and there's a blank space here, and usually you'll see a comma here, and or it will be verbally this is x when or if. Okay, I'm just going to write this in here. So f of x is equal to x if or where x is greater than or equal to 0. And f of x is equal to negative x when or where or if x is less than 0. And so the function, when x is non-negative, the function simply returns 0. When x is negative, the function returns the opposite number. So, in other words, our output is always going to be a non-negative number. And again, it says, A, complete the input-output table for f of x, and here we have the piecewise function, and we have f of x equals absolute value of x equals x, and this comma means when or if x is greater than or equal to 0. So if x is greater than or equal to 0, where do we have greater than or equal to 0? For these numbers here, 0, 4, and 8. And so when x is 0, f of x is 0. When x is 4, f of x is 4. When x is 8, f of x is 8. Now, negative x when x is less than 0. So here we have negative 4. And so if we have negative x, we're going to have negative 4 is going to be equal to 4. And likewise for negative 8. Negative 8 is equal to 8. So we are never going to be negative here. Let's go on. Plot the points you found on the coordinate grid. Use the points to complete the graph function. And so the points were, just reminding myself here, 0, we have 4, 4, 8, 8. So you got 0, 0, 4, 4, and 8, 8. So here we are. And then where x is negative, we have negative 4, 4. We have negative 8, 8. So we are at or above the x-axis for this parent function. So let's go ahead and complete this. Now it says now use the points to complete the graph function. Now one thing we can do now is we can draw in the relation here. on each side. For freehand drawing, that's not so bad. Let me come over this way. On this tablet, it's hard to make straight lines much. So here we have it. Okay. Now, examine your graph of fx equals the value of x and complete the following statements about the function. The graph of fx equals absolute value of x is symmetric about this y-axis here. I'm drawing this vertical line along the y-axis. So we have symmetry about the y-axis. Y-axis. And therefore f of x is an even function. We've talked about this a little earlier in this class. So domain of f of x equals absolute value of x is, and we have the different notations. I'm going to stick with our interval notation, greater than negative infinity up to less than infinity. And so that's going to be interval notation. You can also see this as absolute value, not absolute value, inequality notation. And you can even see this as set notation. And one way, there are different ways for set notation. X such that x is greater than negative infinity and less than infinity. And the range of f of x equals absolute value of x, we have a lower limit, a lower boundary of 0. So in interval notation, we write that as opening bracket, 0, comma, infinity, close with parentheses. And for any quality notation, we could just write it as x is, I said x, I didn't mean x, did I? I meant y. Y, that's going to be the y. And here y is greater than or equal to 0. And in set notation, y such that y is greater than or equal to 0. Okay, next, use the definition of absolute value to show, no, I'm not going to do that. Explore 2, predicting the effects of parameters on the graph's absolute value functions. And here we have the general transformation function, and I've already explained some of this notation in speaking about quadratic functions, for instance. And we covered some of this when we looked at graphical transformations. And so a more specific application is this one here that I've circled. G of x equals a times 1 over b, and absolute value bracket, 1 over b, quantity x minus h, and at the end plus k. And a lot of times I tend to look at this a and b together, and we're going to talk about what they are. A is going to be the vertical stretch or compression, and B is the horizontal stretch or compression. And here we have the graph of absolute value of x shown, and then it says the graph of G1 of x equals absolute value of x plus 6 will be the graph of f of x equals absolute value of x translated. What is this plus 6 going to do? Well, what these are, and it says confirm with the graphing calculator. Well, K here means translates up and or down, right? Up or down. H here is going to be left or right translation. And then A and B is going to be the stretching or compressing. Okay, it says predict what each one's going to look like and graph the function. Well, this is, if we look at the k is going to be plus 6, so we're going to be translate up or upward 6 units. And how do we, it says predict, we're going to use a calculator just to check. So go to TI 84C calculator and find absolute value. There are a couple different ways I know to do it, one of which is just per second, and then catalog down here. And this first option is ABS up front, which is highlighted. Press enter. So we put the X in here, and then we just arrow to the right one and put plus 6. And then we graph, if we have a standard window, we're going to see this arrangement here. And I'm going to go get the grids out of here for second format. And I'm going to go to get a grid line. Oops. Enter. And see what we get by graphing again. So I have grid lines. That's going to help us out. I'll just leave it there. Okay, so that's going to be this whole thing, but moved up 6. So what I'm going to do is something with this smart notebook software I have. Go down here and just trace over the parent function. And then what am I going to do? Well, if you've seen me in class, you know I'm going to just lift it up here. And we're going to translate up 6 units. So there it is. And then we say, then the next one, the graph of g of x equals absolute value of x minus 4. So it's going to be the graph of f(x) equals absolute value of x translated, what? Down 4 units. Okay, we're going to do the same thing here. And translate graph down 4 units. There, done. Let's go on. The graph of g1 of x equals absolute value of quantity x minus 3 will be the graph of fx equals absolute value of x, what? Translated, well, this is the x minus h in the form x minus h. And h is going to be shifting the graph of the function left or right. And I have a little song that I sometimes x plus moves to the left and x minus to the right. Is this x plus or x minus? X minus to the right. So we're going to translate to the right. I'm going to say translated to the right or rightward. That means to the right. 3 units. And so we can take this. What's that going to look like? Oh, that's kind of messy. Okay, and so we take this, move it to the right 3 units. So there it is, to the right 3 units. And then the graph of g of x equals absolute value of x plus 5 will be the graph of f of x equals absolute value of x translated 5 units to the left. And so we're going to take this, same thing, x plus moves to the left and x minus to the right. So we'll go to the left. And let's see, these are 2 apart, so that's going to be 5 to the left right there. Okay, let's go on. The graph of g of x, g1 of x equals 1/4 x will be the graph f of x equals absolute value of x compressed. Well, again, I'm going to go ahead, I know what this is, but I'm going to go to the calculator just to show you this. We have 1/4 x, and here it is. So I'm going to clear this. I'll put 1/4. I could put 0.25, but I'll just go like this, 1/4. And we're going to have absolute value of x. Now, this time I'm going to go to math, and I'm going to go to the right one where it says number, and then under that is ABS. Press enter there. So we got absolute value brackets, but using a different method. And then I'm going to press graph. Now, so what you're doing here, you're getting 1/4 of the amplitude. So this is the 1/4 x. The absolute value of x is going to be just this one here. Okay, x. This red graph is going to be, and so we see that we have 1/4 of the amplitude here, this blue one. So we say compressed, and compressed which way? Vertically. And verbally, we will say this by a factor of 1/4. And then we have this next one, the graph of g2 of x equals -3. Absolute value of x will be the graph of f of x equals absolute value stretched vertically. And I'm going to just abbreviate vertically by a factor of 3. And stretched and reflected about the x-axis. We covered this, I thought, quite well at section 1.3. And so what these look like, well, the first one here, I didn't do that. It's going to be 1/4 of the amplitude. So if we go up 4 here, we're going to go up just 1. So that's 1/4. 1/4. So 1/4 is going to look something like this. Okay. Okay, and next it says by a factor, vertically stretched by a factor of 3. So what that means is, and we're going to be turning this thing upside down and do this in red. So by a factor of 3, we're going to take where this is 1, would be up 3, but we'll bring this down below the x. So if we go over to the left, we're going to go down this much, and then over here too. So we have symmetry. So we're going to be looking something like this. Yeah, that's about as good as I'm going to get it to look here. Freehand like this. Okay, and then if we go to the calculator, we can take a look at that too. We could say -3 absolute value of x. In black we should see it this time. Okay, and then we don't see, and we have the portion is not square because of the, we have more like, we can get that square by going to zoom square. We're seeing more of a proportional sort of a relationship, the graphical proportionality. So that's what that looks like. Next. Now here we have the 1/4 inside instead of outside. So just for convention's sake, we say, or the book says, I like to consider all things stretched or compressed vertically, but this is the meaning of horizontally. So what you're doing is you're stretching horizontally by a factor of, you could say 1/4, or it's at b is 4. Remember, we had this inside here, we had 1 over b by a factor of 4. And it's going to be the same as that 1/4 thing we did originally, right? So that 1 is going to look like this. That's what that one's going to look like. And then it says the graph of g of x, g2 of x equals absolute value of negative 4x will be the graph of f of x equals absolute value is compressed horizontally, abbreviate that, by a factor of 4 and reflected about the x-axis. Now let's make sure that's right, because sometimes when you go inside parentheses, you sort of just flip about the y-axis. One beautiful thing about our calculators, we can always try, can't we? So I'm going to go clear these things out. Actually, here's what I'm going to do. I'm going to clear that out, and I'm going to go here and delete, delete, and then come inside here and press second enter. So I'll put negative 4, and we'll see what happens. Now, do you see in this case we are not reflecting about the y-axis, are we? We have to have the negative sign outside to turn the thing negative, but we are not internally reflecting. So was I right in what I put up here earlier? No, I was not right. And we're reflecting about the y-axis. We are not going down below the x-axis. So that's what this one is going to look like. It's going to be 1, 1, 2, 4. So it's going to go like here. Okay, so that's a notable difference there, isn't it? One reason it's good to use your calculator. Check what's going on. Yeah, because what happens, remember the absolute value, is the absolute value turns anything inside of absolute value brackets positive. So that is going to change this altogether. Good catch. Okay, I'll reflect. And the takeaway here is this implies that A equals 1 over B. I think it says any values for which the relation doesn't work. Yeah, if you have a negative sign inside the absolute value brackets. Okay, graphing absolute value functions. I don't want to do too much here. Let's just go through here. Do part B here. We have g of x equals absolute value of negative 1/2 x plus 3 plus 1. And what this is going to do, this is going to, we'll just follow this. The graph of g of x, the graph of f of x, translated. Okay, we are translating how many units? Well, it's x plus moves to the left and x minus to the right. So 3 units to the left, units to the left, and 1 unit up or upward. And so the vertex of the graph will therefore be the coordinate pair, -3, 3 units to the left, -3, comma 1. And what I'm going to do, and I'm going to graph this in the calculator, kind of to be sure of this. So we go here, we say alpha -1/2, and we come here, we get parentheses. I'm going to go to second INS. We have, make sure I get this right, quantity x plus 3 plus 1. Close parentheses. I'll delete the rest of this. And then we come outside here, plus 1. And we graph the function, this is what we get. See, the vertex is 3 to the left, 1 up. So that's exactly right. Let's go ahead here. This next, determine where the points 2, 2 and -2, 2 on the graph of fx will be mapped. Well, here's our vertex according to this one here. We went 3 to the left and 1 up, so that's where our vertex is going to be. And then we have this -1/2. Well, that's going to be, since absolute value b is 2, the graph of g of x is also a transformation or a compression. That can be there are different words in there. You can say, yeah, I can't really read the mind too well. Now the x-coordinate is multiplied by a factor of this. So I'm not going to go further into this, but here's what we're going to have 1/2, and it's going to be positive 1/2. So we're going to go to the left, up 1, and over 2. So if we go up 1, over 2, we're going to look something like this. And we have symmetry about this vertical line, y equals -3, or x equals -3. And so we're going to look like this. So I'm not going to get into that. Okay, y coordinates will increase, but that's essentially what it does, and that is verified 100% of what we see in our graphing. Let's see if there's anything else I want to do in here. Yeah, what I want you to do is I want you to go ahead. It says given g of x equals -1/5 of absolute value of quantity x plus 6 plus 4. Find the vertex and 2 other points on the graph of f of x and use them to help you graph g of x. So I want you to go ahead and do that, and just pause the video, and then I'll show you here in just a little bit. Okay, what you do is you have, in the original format, we have f of x is equal to a times the absolute value bracket of 1 over b times quantity x minus h, close absolute value bracket, plus k. Right, so our vertex our vertex is going to be the coordinate pair h comma k. When we do quadratic and other functions, the same thing. So here we have x plus 6. Well, that means we have to have x minus, x, to get x plus 6, we have to add x minus negative 6. So our vertex, in this case, is going to have to be the coordinate pair negative 6, because that x plus 6 is going to move to the left. And then k is going to be 4. So our vertex is going to be negative 6, which should be there, comma 4. And that's the vertex. And two other points. Well, we can use other points if we want to. If we say we have this negative 1/5, I know what it's going to do. It's going to go down 1 over 5. So if we go like down here 1 and over 5, down 1 over 1, 2, 3, 4, 5, that's what the thing is going to look like. It's going to go like that. Or we can go ahead and let's say pick out other points. If we pick out 0, what do we get? F of 0 is going to give us one other point, and that's going to be, in this case, negative 1/5 absolute value of 0 plus 6, which is going to be 6 plus 4. So we get negative 1/5 of 6, so that's going to be negative 6/5 plus 4, and 4 is 20/5, and negative 6 plus 20 is going to be 14/5. And decimalized, that's going to be 2.8. So at 0, we're going to go up to 2.8, and that's going to be about right here. All these are 4, right? So about here. We can pick another point to the left. We can put it here, negative, I don't know, negative 20. F of negative 20 is going to be equal to negative 1/5. We have absolute value of negative 20 plus 6, and that's going to be plus 4. So we're going to have negative 20 plus 6, that's going to be negative 14. So we have negative 1/5 times absolute value of negative 14, and then we have plus 4. Well, this negative 14 is going to be positive 14, so we're going to have negative 14/5, and it's going to be plus 20/5, so that's going to be equal to 6/5 at f of negative 20. Well, here's f of negative 20. We have 6/5, which is 1.2, so it's going to be about right here. So this is what the thing's going to look like. Not too pretty, but that's what it's going to look like. Then if we go to our graphing calculator, we should see exactly that. So I'm going to come down here. Well, I'll just put out here negative 1/5. Come over here, absolute value of, second catalog, enter, absolute value, and we had x plus 6. We'll close that parentheses, come outside, plus 4. Here's what we're going to see. have the graph. You see that? And to get it like it was, I'm going to do two things. I'm going to get rid of this thing here, and I'm also going to go up and get the window right because they're going by 4 on the X scale and also on the Y scale. 4. So I do that, you should see a similar thing. So that's what we see, isn't it? You can look at this over here. And the last thing we could do is we can get exactly the same. But look what we do over here. It's just exactly what it is, right? Exactly. There's the point. There's the x-intercept. So we can write absolute value functions from a graph, and I'm not going to go ahead and do that today in this. I think the video is already long enough, and we have the essentials, and we'll be able to work through the exercises. So that's basically it for this video lesson. Good luck, and thanks for viewing.